Mobile robotics is the discipline that studies the design and development of robots that move all around, so that they are not constrained to the same physical location. So that entails, for example, ground robots or flying robots like quadcopters, hexacopters, drones, airplanes, as well as underwater robots.
As part of NCCR, we were looking into applications that included, for example, search and rescue. So environments that are completely unknown, very different every time, and the robots have to deal with the biggest challenge they can think of.
Heterogeneous teams of robots such as swimming, aerial and ground robots helping out rescuing teams can be key to tackling the robustness of our algorithms. So for the moment, I would say within the research labs, we're doing a lot of work on individual robots, but I think we have a long way to go.
Legged robots are revolutionizing mobile robotics because they offer a new level of mobility. In contrast to wheeled or tracked vehicles, they can literally go anywhere. They can move across stairs, steps, all kinds of obstacles. If there's gaps on the ground, things that weren't been possible before. We started a commercialization phase through these spin-offs, which have created from a prototype a full product that is now already in use in different industrial facilities.
Today, aerial robots are already wonderful tools to take images from the air or do other measurements. They are used in mapping the environment, mapping fields for agriculture, or, for example, in search and rescue missions. NCCR-robotics did a wonderful job by designing new type of robots. So it's really new arrangements for delivery of goods, for example, or for interacting with the environment. We did also a lot of progress in control, using also latest technology in learning. For example, that robots can learn to go at very high speed, or for really doing some special maneuvers which are very difficult to program in advance.
Swimming and amphibious robots are robots that can, first of all, swim, move around in water, but then able to move out to do inspection also outdoors, on ground, on dry ground, and especially be at the interface, which is very tricky for robots. So within NCCR, we have done several very exciting developments in amphibious robotics. A croc robot is a kind of reptile, crocodile-like, salamander-like robot that can swim and walk. Another one I like a lot as well is more scientific. We worked with neuroscientists to understand how these neural circuits in animals have reorganized themselves during the evolution. And finally, a very cool project we had is called the Orobot. We revived an animal that only exists as a fossil. And for me, it was a very exciting way of using robotics in a new way to answer a scientific question.
Mobile robotics now is, I think, the new trend. These robots are going to be, I think, part of our life in the short future because they don't really need manipulation. They are just, moving objects.
The future of mobile robots, in my opinion, is that we are going to be surrounded by robots and going to be helped by robots in all our daily tasks. That goes from, for example, helping elderly people, as well as, for example, flying cars, flying taxis. This is already happening a little bit right now, but at the moment these are just prototypes, so it will be about porting the same drone algorithms to flying cars. And then ultimately what we will witness in the next decades is that actually robots will conquer other planets and possibly other galaxies much earlier than humans.